Good morning, Excel Geo. What we're going to do today is we are going to talk about our last concept that we're going to learn this year. And we're going to talk about law of sines and law of cosines. Today, we're going to focus on law of sines. And then tomorrow, we are going to introduce law of cosines. So that's what we're looking at today, law of sines. Now, let's talk about what we've learned already this year and what you've learned in other years. Now, when you think of the Pythagorean theorem, we have a right triangle. We talk about the Pythagorean theorem. And we know a square. Let me get it a little thicker. I know. My A's aren't coming. Let's try it this way. A squared plus B squared equals C squared. And that theorem is great, but it only works with a right triangle. So we can only use the Pythagorean theorem to find other side lengths when we're given a right triangle. Same thing with trigonometry. We can only use our sine, cosine, tangent, meaning our SOHCAHTOA, or sine, cosine, tangent ratios when we are given a right triangle. So what happens when we don't have a right triangle? What if we are missing sides or angles of triangles that are not right triangles? Law of sines and cosines to the rescue. Okay, so we're going to talk about how we can utilize law of sines and law of cosines to solve oblique triangles. And when I say oblique triangles, I mean triangles that do not have a right angle. So what were the different side angle combinations for proving triangles congruent? Now, if we think about that, we had like an angle, angle, side. We had an angle, side, angle. We had a side, side, side. We had a side, angle, side. And then we also had and if we remember, side, little side, angle, where your angle was obtuse. Okay. So, we also had like an HL, but HL was pretty much for right triangles. So we're not going to have to worry about them. And we're also not going to worry about SSA, S little SA. So these are the two that we're just not going to worry about. We're going to focus on the four that are in purple. All right. That's what we're going to focus on. Okay. So if we take a look at that. Now, what didn't work is if we just had SA, and say A was an acute angle. That did not work. So we had examples that did not work. Noting that angles and sides were given will help us solve triangles. Okay, so we're going to talk about that. Meaning, when I say noting what angles and sides are given, we mean, is the angle included? Is the angle not included? Is the side included? Is the side not included? We're going to have to look at that. So today we're going to start with law of sines. And this is our law of sines formula we have right here. Now, law of sines is a ratio saying if I have an oblique, and when I say oblique triangle, meaning a triangle where we do not have a right angle. If I have an oblique triangle, the ratio of A, side length A over sine A. And I'm actually going to edit this a little. Okay, guys? When they have on the bottom, it should be all the angles. So I tend to do all the angles in capital letters. So let's make, I don't want all A's. I want all the angles in capital letters. So that means I have an A, my second one be a capital B, and my third one be a capital C. All the angles, so all the bottoms should be capital letters, okay? So that means the ratio of side length A over the sine of angle A is equivalent to the ratio of side length B over the sine of angle B, which would be equivalent to the ratio of the side length C over sine of angle C. This is our law of sines for a triangle. So when can they be used? Can be used to solve triangles where we know, and this is the key thing, two angles and a side. So this can be used when we're given angle side where the side is not included and angle side angle where the side is included. Those are the two cases where we can use law of sines to solve our oblique triangles, meaning our triangles that are not right. So let's scroll down. Here's an example one. Given two angles and a side. So this is our first example, angle, side. Solve means the same when we solve right triangles. When you're asked to solve a triangle, you're asked to find all the unknown parts, meaning unknown sides or unknown angles. Now, if you're given two angles, the easiest thing to do is find the third angle of your triangle because we know our triangles add up to 180 degrees. So if I take a look at this, I see I have C is 107 and B is 25. So if I want to find A, I would know, let me get out of that. I would have to just say, how do I find my A? Now, if I'm saying, how can I find my A? What you're going to do in this case is say, well, I'm going to take 180. I'm going to subtract 107. And then I'm going to subtract 25. And when I do that, you should get the angle to be 48 degrees. That should be angle A. All right, guys? So there we are. Now, we have angle A. Now, why was it necessary to get angle A? Once we have angle A, we're able to set up proportions for everything to find all our unknown parts. So let's take a look. All right, so I know angle A, I could put 48 right here. So now I need to find my unknown sides. The sides I need to find are A, and I have to find C. I can pick which one I want to find first. Now, in order to find one, I need to know one side and its opposite angle. So if I look at this, I know B and I know the angle B. That's the ratio I have to find first, meaning I have to use what I'm given. So that means B over the sine of B is given to me. So I know, what is that? That's going to be 15, right? So that means that's 15 over the sine of 25 degrees. That ratio would have to be equivalent to another side and angle, all right? Now, I just want to emphasize here, you're going to notice that little a is always going to be across from angle A. Side length B is always going to be across from angle B. Side length C is always going to be across from angle C. So that's why you're looking for the ones that are across from each other. So say I wanted to find A first. I would set this up and say I want to find A would have to be over sine. Now I know the angle A is 48 degrees. So how do I do that? So let's cross multiply. You do 15 times sine of 48. Make sure your calculator, guys, go to mode and make sure your calculator is in degree. 15 times sine of 48 would equal A times the sine of 25. So what you're going to do is then divide by sine of 25 to find that A value. That means if I did that, I'd take 15 sine of 48 and divide by sine of 25. Don't forget to close your parentheses of that sine of 48. You should get A to be about 26.376. And I'm going to do 3 decimal places, guys. All right. That's A. So now I'm able to find A. So I can label that 26.376. Now to find C, again, since we do not have a right triangle, we have to stick with law of sines. So if I'm finding C, I'm going to still use my B ratio because I have no rounding in it. I have 15 over sine of 25. I don't have any long decimals. It's an easier ratio to use. So if I write this is over sine 15 over sine of 25, in this case is going to be equal to C over the sine of the C angle, which is 107. And we're going to do the same thing. You're going to cross multiply 15 sine of 107 equals C times sine of 25. So to find C, I'm going to multiply 15 times sine of 107. I'm going to close the parentheses and then divide it by sine of 25. And you're going to get C to be approximately 33.942. And you're going to see, guys, we solved for every unknown in our triangle using law of sines. All right. Okay, guys, take a look. That was when we had 2 angles and a non-included side. The side was not between the 2 angles. But we can still use law of sines when we have 2 angles and an included side. So that's what we're going to look at next in example 2. So in example 2, I have 2 angles and an included side. So let's take a look. Again, when you're given two angles, the easiest thing to do is to find that third angle by subtracting the two in which you're given from 180. So you got 180 minus 115 minus 30, and you're going to know now that angle A, sorry guys, moved it a little. I'm going to know that angle A equals 35 degrees. So I can put that in. Now that helps because now, remember, the ratio that's going to help me is when I know a side and an angle directly across from it. That's the ratio I'm going to start looking at. Because remember, little a is always across from big A. Little b is always across from big B. Little c is always across from big C. So if I look at that, the ratio that's going to help me here is I know 30 over sine of 35 is going to help me find my other measurements. So now if I want to say find B now, I would take little b and put it over sine of angle B, which is 30 degrees. So what are we going to do? I want you to cross multiply. So again, you're going to get B sine of 35 equals 30 sine of 30. And you'll divide by that sine of 35. So when we put that in our calculator, you do 30 sine 30, close that parenthesis, and divide it by the sine of 35. And you should get your B value to be 26.152. So the next thing we're going to look at, let's take a look. Now let's find C. I'm still going to use that A, that 30 over sine of 35, because I don't have any long decimals in that ratio. So it makes it easier to work with. And I'm going to set that equal to C over sine of 115. So let's take a look. What do? Again, I cross multiply. 30 times sine of 115 is going to equal C times sine of 35. So I want to find that C. I'm going to take 30, multiply it by that sine of 115 in my calculator, close that parenthesis, and then divide it by the sine of 35. And I'm going to get C to be approximately 47.403. So I now have found my three unknowns of my triangle. A is 35, B is 26.152, and C is 47.403. All right. All right, we're going to get into law of cosines tomorrow. So you have a homework assignment for tonight. But actually, you know what? Let me add a problem here before we do the homework assignment for tonight. So let me just go over one more thing. If I gave you another example, like 3, all right? In 3, I'm going to give you B equals 102, C equals 17, and we'll say little a equals 5. Now, guys, if I give you a problem like this, and this is how your homework is set up, you're not given the triangle. So what are you going to do? You are going to draw the triangle. And when we draw that triangle, and I draw my triangle, I know that if I take a look at this, I have A, B, C. Label your vertices. Label the sides across from the same letter. So big A, I have big A here. I go, what's across? Across from big A is little a. So now I go to my next one. I go B. Across from big B is little b. Then again, C. Across from big C is little c. That's how you're going to construct your triangles when you are solving using law of sines. So now I can label my parts to make my life easier. I have A, I know 102 for B. I know C is 17. And I know A is equivalent to 5. And that's how I would look at it. Now, I would still find, when I solve it, you're going to find the angle A obviously first. And the reason we're going to find angle A first is because we're given two angles, and we can easily find angle A by subtracting 102 and 17 from 180. So I know angle A is 61 degrees. Now I can say, okay, what do I know? What ratio do I visually see now? I have both my A's, my side length A and my angle A. So I'm going to use them, that ratio, 5 over sine of A to find, I'm sorry, but sine of 50, we already know what A is, of sine of 61 to find one of my other letters. So let's say B. I would do B over sine of angle B, which we know is 102. So to find B, again, we're going to cross multiply. So I have 5 times sine of 102, I put in my calculator, close that parenthesis, and then divide it by sine of 61. So your B will be 5.592. Then what I did is I cross multiplied and then divided by sine of 61. Okay, now let's take a look at our next one. Let's take a look at your next one. Should be 5 over sine of 61 equals C over sine of 17. So let's take a look. So now I'm going to do 5 sine of 17 divided, make sure you close the parentheses to that sine of 17, and then divide it by sine of 61. So you're going to get C to be 1.671. So now I should have all my unknowns. Okay, so we have the unknown angle. So let's do red, different color. I have an unknown angle of 61. And then I have my B and my C. So I have solved that oblique triangle. And again, oblique means a non-right triangle. The rest of this note sheet we are going to be using tomorrow. So make sure you just keep it if you printed it out. Your homework is attached below. It's called Law of Science homework. That is your assignment for today. Please upload it when you have completed it. And if you have any questions, please attend office hours. I hope you guys have a great day.